Welcome to the debate. It is Wednesday, January 21st, 2026. So, the honeymoon is officially over. For the last 2 years, we've watched the corporate world engage in this frantic, almost delirious love affair with generative AI demos. We've seen the magic tricks, right? The chatbots writing poetry, the image generators, all of it. It was the wow phase. But today we are looking at a cold, hard reality check. We're discussing Samuel Williams' provocative new piece, 9 game-changing predictions for 2026, which just came out on datapro.news. And the headline might as well be, "The bill has arrived."
And what a staggering bill it is. I mean, Williams frames this shift as the transition from the demo phase of 2025 to the industrial phase of 2026. But frankly, reading through these 9 predictions, it feels less like a maturation and more like a hostile takeover of the entire engineering discipline. We're seeing a move toward what he calls inference economics and zero ETL, which to me, it just reads like a roadmap for fragility. It feels like we are dismantling all the safeguards of traditional engineering just to chase a lower bottom line.
I see why you might feel that way, but let me offer a different perspective. This isn't a takeover. It's a necessary professionalization. The central tension here is clear. We are moving from can we build it to, well, can we afford to run it without being sued? We're talking about the radical reorganization of data engineering that's required to support AI that actually works on a Monday morning in a production environment. I'm arguing that the shift to what Williams calls context engineering and automated governance is the only way to make AI viable, defensible, and cost-effective. If we don't adapt, the ROI simply isn't there.
And I come at it from a completely different angle. I look at this roadmap, this move toward decentralized architectural sprawl and automated vendor-controlled governance, and I just see a recipe for disaster. We're trading the stability of traditional engineering for this complex web of self-healing systems that we barely even control. We are risking security and operational sanity just to lower the monthly token bill. We are essentially handing the keys to the kingdom over to vendors and algorithms and just hoping they drive better than we do.
So, okay, let's get right into the thick of it. The time for theory is past.
Agreed. Yeah, let's do it.
Let's start with the elephant in the room, or I guess the elephant in the CFO's office. Williams opens his piece by noting that the AI strategy slide of 2025 has been replaced by a bill in 2026. And he's not talking about pocket change. We are seeing enterprise AI bills measuring in the tens of millions of dollars per month.
That is an undeniable fact. The usage has it's ballooned. But we need to explain why that bill is so high to really understand the reaction. It's not just storage anymore.
Exactly. It's the inference costs. And to put it simply for our listeners, every time an employee asks an agent a question or an automated system processes a document, models are running. Tokens, these little chunks of text, are being generated. Cloud compute is spinning at a massive rate. This brings us to prediction 1, inference economics. This is the most critical driver for this year. We cannot ignore cost anymore. The article states clearly that data engineering is being pulled into FinOps, financial operations, by necessity. The days of just throwing data into a massive cloud warehouse and hoping for the best are gone. We have to design platforms where cost is a constraint, just as important as latency and correctness.
I'm not disputing the bill. I'm not. But I am deeply concerned about the proposed solution. Williams suggests that to manage these costs, we're moving toward context engineering and zero ETL. He's effectively saying that manual pipelines, the code engineer's right to move data, are dying, and that we should rely on low-code, managed replication. I'm sorry, but I just don't buy that as a safe path. You're talking about zero ETL, essentially letting a vendor magically move your data without you writing any code as a survival mechanism. But Prediction 3 frames it as a mandate. When you strip away the manual engineering, you aren't removing complexity, you're just hiding it inside a vendor's black box.
But that's the point. The engineer shouldn't be pulling levers on basic replication anymore. It's just undifferentiated heavy lifting. We need to move up the stack. If we're spending our time writing basic Python scripts to move data from database A to database B, we aren't focusing on the high-value work of making sure that data is actually understandable to an AI. We need to be architects, not plumbers.
Or we're moving out of the driver's seat entirely. Look at Prediction 4 about open table formats like Iceberg and Delta Lake. Williams explicitly warns that while storage lock-in is decreasing, meaning you can store your data anywhere, the catalog and policy layers are reintroducing lock-in at the governance level. So we are walking straight into a trap where we think we're free because our data is in an open format, but the metadata, the definitions of what that data actually is held hostage by a proprietary governance layer.
That is a risk, I'll admit that. But look at the alternative. We have agents, these autonomous digital workers that need reliable data now. Prediction 6 tells us that loading overnight is a confession of failure. We have to move to streaming. We have to move to automated governance. The speed of business it's outpaced the safety of the nightly batch job. We can't ask the AI to wait until tomorrow morning to know what happened today.
And that speed is exactly what worries me. But let's break this down systematically. You're championing this inference economics model. Let's look at what that actually does to the architecture of our systems.
Let's do that. Because Prediction 1 and Prediction 7 they're inextricably linked. Williams argues that because of these massive costs, we're seeing a hybrid strategy become strategic, not just some legacy holdover.
Right. The idea that development happens in the cloud, training the models on massive GPU clusters, but the high-volume inference moves to the edge or on-prem.
Precisely. It's simple math. You cannot pay cloud egress fees, the cost to move data out of the cloud, and compute fees for every single token when you're running high-volume inference. I mean, imagine a retail chain with 5,000 stores. If every single inventory query from every store goes to a central cloud model, the bill just destroys the margin. The article predicts that data engineers will have to design for a split-brain reality. We need to push small language models, SLMs, and vector databases out to the edge.
Okay, let's just clarify that for the listeners because these terms get thrown around a lot. An SLM, a small language model, is a much smaller, cheaper AI model that can run on a local server or even a laptop, unlike a massive model like GPT-4 that needs a whole data center.
Correct. And a vector database is what holds the memory or the context for that AI. It stores data as mathematical coordinates so the AI can find similar concepts quickly. So we're pushing the brain, the SLM, and the memory, the vector DB, out to the edge, close to the user. This isn't about preference, it's about survival. The winning solution in an architectural review is now the one that reduces retrieval calls and eliminates wasteful recomputation.
I see why you think that makes sense financially, but let me give you a different perspective on that. You call it economics, I call it architectural sprawl, which is exactly what Prediction 7 warns about. We're moving from a central, governable warehouse where we know exactly where all the data is to an ecosystem of distributed context stores. I mean, just think about the operational overhead. You were talking about synchronizing a triad of SLMs, vector databases, and graph databases across potentially hundreds or even thousands of edge locations.
It is complex, yes, but it's the only way to scale.
It's not just complex, it's a security nightmare. Williams notes that decentralization widens the attack surface. When you have intelligence at the edge, you have sensitive context at the edge. And you have synchronization issues. How do you ensure that the context at the edge matches what's in the core? If a price changes in the central database, how fast does that update propagate to the vector database in store number 402? You're creating a distributed system consistency problem that most data teams they're simply not equipped to handle.
I'm not convinced by that line of reasoning because it assumes we have a choice. The alternative is a centralized system that is just too expensive to turn on. Yes, it creates a split-brain reality, but that is why the role of the data engineer is evolving. We aren't just pipe builders anymore. We are systems architects. We have to model the unit economics. If an agentic workflow costs $5 to run because of inefficient retrieval, it doesn't matter how secure it is, it won't get deployed. We have to embrace this distributed complexity to make the technology affordable.
So we break the architecture to save the budget? That seems like a really short-sighted trade. You're prioritizing the OpEx, the operating expense, over the systemic risk. You're basically creating thousands of little islands of data that can all just drift apart.
We evolve the architecture to save the business. And this leads directly to the second major shift, what we're actually building. We aren't building dashboards for humans anymore. We're doing context engineering.
Prediction 2. The job title stays, but the work becomes context engineering for agents.
Exactly. Williams makes a really profound point here. Agents are not just chat interfaces. They're role-based digital workers. They decompose goals, they delegate tasks. They don't just need data, they need reliable context. They need semantic correctness. If an agent hallucinates, makes up facts because the data was stale or the schema drifted, that's not a chart failing to load. That is a digital worker making an expensive mistake like ordering the wrong inventory, mispricing a contract, or sending a sensitive document to the wrong client.
That is a compelling argument. But have you considered what is required to actually support that level of reliability? Williams talks about prediction 5, self-healing pipelines. He says we need dense observability, pipelines that emit schema fingerprints and partition counts. He says we need systems that can detect, diagnose, recover automatically.
And that is the future. We need pipelines that can adapt their logic on the fly. If the data format changes slightly, maybe a date field switches format, the system should recognize it and adjust rather than crashing at 2 in the morning.
But that is why we replace alert and fix with detect and recover. Humans are too slow. If you wait for a human to wake up, read a Jira ticket, log in, and fix the pipeline, that agent has already served bad answers to 1,000 customers. Speed is the new safety. Humans are the safety valve. Williams discusses prediction 8. Governance stops being stewardship and becomes automated enforcement. He describes agents that generate their own quality tests and classify their own sensitivity. This is governance by exception. You're removing the human steward and relying on the very technology that causes the hallucinations to police itself. It makes the system incredibly brittle. If the Sentinel fails, the whole thing just goes off the rails.
I think you're clinging to a model of manual oversight that simply cannot scale. We're dealing with streaming data, open table formats, and agentic consumers. You physically cannot have a human review every schema change or every data contract.
Which brings us right back to the zero ETL trap.
It's not a trap, it's a baseline. Prediction 3, zero ETL will be the default starting point.
Okay, let's define zero ETL clearly for anyone who hasn't fought with it yet. It's a marketing term. It implies you don't do any extract, transform, load work. In reality, it means the database vendor builds a direct pipe to the data warehouse. And it sounds convenient, but Williams writes that failures in zero ETL are treated as operational negligence. Here is the reality. Zero ETL is just vendor-managed replication. If I'm an engineer and my job is to ensure reliability, but I'm forced to use a black box connector that I didn't write and can't debug, I'm in a position of maximum responsibility with minimum control.
You're looking at it like a mechanic who's mad they can't tune the carburetor on a Tesla. You're in a position of high-level architectural management. The article says clearly, the organization still needs expertise, but it gets redeployed. You aren't building the connector, you are hardening the system around it. You're managing the data contracts.
Ah, yes, the data contracts. Prediction 8 again? Contracts increasingly enforce validity at the source.
Yes, this is the only way to survive regulation. If we don't have enforceable contracts that prevent breaking changes from cascading downstream, we're liable. We need automated enforcement. You seem to want to keep this heroic pipeline craftsmanship, but Williams is telling us that era is over. We need machine-consumable data products, not bespoke artisanal pipelines that break when the creator goes on vacation.
I don't want artisanal pipelines for the sake of art. I want control for the sake of sanity. Let's look at prediction 4 again, the political battleground of open table formats like Iceberg. You say we need automated enforcement, but who owns the policy layer? Williams warns that vendors are pitching control as convenience. He says, the central contest is no longer warehouse versus lakehouse. It is who owns the definitions.
Expand on that. What do you mean by definitions?
I mean the metadata, the logic that says this column means revenue and only these people can see it. If I rely on a vendor's zero ETL and their automated governance tool, that logic lives inside their proprietary software. So even if my data is in open source Iceberg tables, which technically means I can access it with any tool, if I want to leave that vendor, I leave my definitions, my lineage, and my permissions behind.
I am trapped. I have the raw data, but I've lost the brain that understands it.
That is a risk. But let's be real. The alternative is what? Building your own governance layer from scratch? In 2026? That is just not economically viable. We have to pick a side. And honestly, the biggest risk isn't vendor lock-in. It's the speed of data.
You mean the streaming first mandate, prediction 6?
Yes, this is non-negotiable. We load overnight is a confession of failure. Physics dictates that if embeddings, those mathematical representations of data that AI uses, are generated after data lands in staging, you introduce delay. That delay degrades real-time reasoning. If a customer updates their address and the agent doesn't know about it for 24 hours because the batch job hasn't run, the agent fails. If you want agents to work, you need change data capture, CDC. You need Kafka. You need Flink. You need embedding generation in flight.
In-flight embedding generation. Do you realize the level of operational maturity that requires? Williams compares it to organizations without CI/CD looking archaic. But moving from nightly batch jobs to real-time streaming isn't just a tech upgrade. It's a culture shock.
It is a necessary shock.
It's a dangerous one. As the article points out, breaking changes in streams are far more damaging than a broken nightly job. If a nightly job fails, you fix it in the morning. The data is late, but it's correct. If a stream breaks, or worse, processes bad data in real time, your real-time agents start hallucinating or failing immediately. You're turning every data engineer into a high-stress, real-time ML operations engineer. Most organizations simply do not have the discipline for that.
Then they will fail. That is the harsh truth of 2026. If you cannot handle real time, you cannot play in the industrial AI space. This brings us back to the core identity shift. The data engineer is becoming a product owner with an audit trail. That's prediction 9.
That sounds like a fancy way of saying scapegoat with a log file.
No, it means we are moving from shiny tools to systems that are defensible. We are embedding engineers within business units. They are forward-deployed builders. They have to translate business risk into technical controls. This is the professionalization of the field. It's a quiet coup, as the subtitle says. We're finally being asked to sit at the grown-ups table, to understand the business, to manage the risk, and to own the product.
I agree that the professionalization is happening, but I worry about what we're losing in the process. We're being asked to build context supply chains using tools we don't own on infrastructure that is scattered across the edge, governed by agents we didn't write. The harder question Williams mentions isn't just about the bill. It's about who actually controls the context.
The context is controlled by the systems architect, who models the unit economics and enforces the contracts. That is the new data engineer.
Or the context is controlled by the vendor who owns the catalog and the governance layer. Williams says governance stops being stewardship. I think that is a tragedy. Stewardship, the human care for the meaning of data, is exactly what we need when the systems are this powerful. Replacing stewardship with automated enforcement feels like handing the keys of a Ferrari to a teenager, or in this case, to an agent, and just hoping the lane assist works.
But if that Ferrari costs $10 million a month to run, you better believe we're going to automate the driving to save fuel. We cannot let perfect stewardship be the enemy of economic survival.
And I suppose that is where we fundamentally disagree. I believe that in the rush for economic survival, we are building a house of cards. We're assuming dense observability will save us from architectural sprawl. We're assuming data contracts will save us from zero ETL opacity. That is a lot of assumptions for a system that is supposed to be industrial.
It's not assumption, it's engineering. It's the shift from heroic pipeline craftsmanship where one genius holds the whole system in their head to systematic resilience. It is painful, yes, but the AI strategy slide is gone. The bill is here. We have to pay it. And the only currency we have is efficiency and automation.
I'm sorry, but I just don't buy that efficiency is the only currency. Trust is the currency. And if we build systems so complex and automated that we can't explain why an agent made a decision or where the data came from because it was replicated by a zero ETL process we don't control, we bankrupt our trust.
Which is why Prediction 9 emphasizes the audit trail. We must be able to defend the data choices under scrutiny.
An audit trail tells you what went wrong after the house is burned down. It doesn't prevent the fire.
That's an interesting point, though. I would frame it differently. The audit trail is the prevention because it forces the discipline upstream. It forces the enforcement at the source. If you know you're being audited, you don't make the breaking change.
We shall see. It relies on a level of rationality that is rare in frantic IT departments.
We've covered a lot of ground today. 2026 is shaping up to be a brutal year for the unprepared. To summarize my position, the industrial phase of AI is here. The luxury of the demo is over. We have to embrace inference economics to control the ballooning costs. We must shift to context engineering because agents are digital workers, not toys. And we must accept zero ETL and automated governance not as constraints, but as the new baseline for professional, defensible systems. The data engineer is evolving into a product owner, and that is a good thing.
And to summarize my view, the professionalization is real, but the dangers are hidden in the convenience of these new tools. By decentralizing the stack to the edge, splitting our brains across 5,000 stores, we're inviting architectural sprawl and security risks. By embracing zero ETL and vendor-led governance, we are trading our craftsmanship for lock-in and opacity. And by forcing a streaming-first mandate, we're introducing fragility into systems that are not yet mature enough to handle it. The bill is real, but the price of paying it might be the stability of the very systems we're trying to build.
It seems we both agree that the era of the heroic pipeline builder is ending. The disagreement lies in whether this new era of context engineering liberates us or traps us in a web of distributed complexity.
Indeed. And for our listeners, the question you have to ask yourself is simple. When that AI strategy slide turns into a $10 million monthly invoice and the CFO walks into your office, do you have a system that is defensible or just a system that is expensive?
That is the question of 2026. Thank you for listening to the debate.
Until next time.